Hello scholars, welcome. Mr. Hinkle here. We're talking about special weather that happens in the oceans, and we cannot forget about hurricanes. Hurricanes are big, they're powerful, they're massive storms, and they cause an extravagant amount of damage and destruction every single year. So let's learn about hurricanes. And what specifically we are getting into is the formation, the structure, the wind speed, the occurrence, the destruction, and the impact that hurricanes can do. So this is a very introductory lecture. A hurricane is a rotating mass of low pressure. It's a storm that develops in the ocean. Wind blows from high pressure to low pressure, and so there is a very low pressure at the center with high pressure surrounding it that causes the storm to have very high winds. Now, hurricanes are experienced all over the world, but they are named differently by location. In the Atlantic and Northeast Pacific, we call them hurricanes. Same storms. In the Northwest Pacific are called typhoons. The same storms in the Indian and South Pacific are called cyclones. So this is the name. The designation is the same, just the name changes based on the location of what ocean. Why that is? That's a good question. I've often thought about why that is, but I don't know. And so I know what I'm going to look up tonight as I'm doing my evening reading before I fall asleep. Okay, so hurricanes need warm water. It is like the fuel that feeds these ginormous storms. And basically what happens is, part one, you've got some warm, humid air that causes a lot of air to rise, generating storms. Well, the rain falls back down and interacts with the warm, humid air at the bottom that further intensifies. So warm, moist air rises, cools to form rains, it condenses. The latent heat of that condensation actually creates more heat, which leads to more precipitation, which leads to more condensation. So it's a self-sustaining occurrence. The heat causes more air to rise, more air condenses, more rain occurs, and then the storm intensifies and it grows. So hurricanes are low pressure storms. Let's do some keys. I did a lot of arm waving there. Low pressure storms fed by warm, humid air. That warm, humid air generates a hurricane. Well, hurricanes have three main parts. In the very center, you've got the eye. Extreme low pressure, very calm. Right around the eye is the eye wall. And this is where the highest winds and the most precipitation is going to occur. Outside of that, you've got the outer bands. There's a lot of rainfall here too. These storms are massive. You can see them from space. But we could technically classify the hurricane into three parts. This is where the term the eye of the storm comes from, because the eye of the hurricane actually is a region of calm, clear skies surrounded by the eye wall and the outer bands. Hurricanes spin, and they travel on nonlinear paths, both because of the Coriolis effect, which is an artifact of the rotation of the Earth and the fact that the circumference at the equator is much larger than the circumference at the pole. So, due to the Coriolis effect, let's talk about hurricanes in the northern hemisphere. The northern hemisphere has, I'm going to use a different color for this. and apparent deflection to the right. So with a low pressure center, that means that there's going to be a slight bend to the right, slight bend to the right, slight bend to the right, slight bend to the right. All the wind rushing from high pressure, which is out here, high, 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 high. All the high pressure rushing into the low pressure center, because that's what a hurricane is. It's a storm centered on low pressure, causes the hurricane to spin in a counterclockwise direction. Now, the whole storm is traveling. They usually start out here, we're going to call this the equator, in the equatorial Atlantic Ocean and end up traveling up the eastern side of the United States. This is also due to the Coriolis effect. So the Coriolis effect does two things. It causes the storm to spin counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, and to bend to the right in the northern hemisphere and bend to the left. And again, I'm going to put this up here nice and big. It's all because of the Coriolis effect. So when we see these storms from space, they look like swirling masses in the sky, which is what they are. They spin because of the movement of the winds being deflected due to the Coriolis effect. These storms generate big winds. So winds less than 38 miles per hour, we call these storms a tropical depression. 38 to 74, they become a tropical storm, and hurricane does not become a hurricane until it reaches wind speeds of, let's put this up nice and big, 78 miles per hour. Let's check my facts. 74, I said that wrong. Oh my gosh, the world is going to end. I made a mistake. 74 miles per hour, which is pretty fast. I don't know if I've ever been outside and winds that big. I've never been in a hurricane, that's for sure. I'm from California, where we don't experience hurricanes because of where they form. We're going to talk about hurricane origination here soon, but first we can categorize hurricane intensity on the Saffir-Simpson hurricane wind scale. Over 74, Cat 1. Over 96, Cat 2. 111, Cat 3. 131, Cat 4. 155, I can't even imagine. That's mind-blowing to me what that would even feel like, what that is even like, causing from minimal to catastrophic damage. And Category 5 hurricanes occur. They occur every single year. So I'm going to refer to the images to explain this one. North America, South America, Africa. So in the tropical Atlantic is where most of the hurricanes exist. They originate. And because of the Coriolis effect, they bend to the right and then dissipate up here in the North Atlantic, where the water is much colder and they no longer have the energy to support them. So originating in areas that are hot and humid, traveling, sometimes making landfall, bending to the right. Hurricane season, no surprise, June through November. It's in northern hemisphere summer, because when the storms originate, it needs the warm temperatures for them to keep going, or else they just dissipate and they kind of lose all of their strength. Here we can see both cyclone and hurricane all over the world. So here in the Atlantic, these storms come up and reach landfall before they travel on. We don't really get many storms here in the the west coast of the United States, because all of these storms that are generating down here lose their steam because there's cold water that's coming down due to the Pacific subtropical gyre that basically takes all of their energy out. Not to say it can't happen, but it's just very rare. You go over here though, again, you have lots of hurricanes occurring because of the direction. So here we see a connection between oceanic circulation patterns and the 5 large subtropical gyres and the paths of hurricanes. Hurricanes can be explained. Why do we have hurricanes on the east coast of the United States, not the west coast? Very simply put, because of oceanic circulation patterns. Hurricanes are very destructive. The flooding, the winds, the rainfall, it can cause billions of dollars of property damage and extensive death tolls, loss of life. They're very sad. The most destructive part is going to be the storm surge, which is basically a big wave. So as these hurricanes are out in the ocean, the winds will create a huge wall of water that when the hurricane gets close enough, it pushes that wall up and over, and it can move very far inland. Waves can be up to 20 feet, spanning hundreds of miles of coastline, and completely inundate and destroy coastal areas. There's been some really bad hurricanes in the history of the world. If we keep our discussion exclusive to the United States, we've seen many, many big destructive hurricanes. The frequency and distribution of global hurricanes is actually increasing. One of the side effects of global climate change that's occurring currently due to the increased use of fossil fuels and atmospheric carbon. But that is another discussion for another lecture. We'll use Hurricane Katrina as our case study. 2005, Hurricane Katrina hits landfall on August 23rd. And it's focused around New Orleans. And New Orleans is built in the delta of the Mississippi River. There's levees that are protecting it from being flooded. And the levees broke because the storms were so big, causing the majority of the city to be flooded. This led to over 1,800, although the number is still not definitely accounted for, 1,800 plus fatalities, over $100 billion of damage, and the response to this was not good. When we look back, the geopolitics of how we were able to respond and provide care to those affected from Hurricane Katrina was not the best that could have ever happened. So it prompted disaster relief changes in our policy in order to ensure that when these things happen again, because they will and they are continuing to happen, we can do better at supporting the individuals who are harmed from these types of natural disasters. So hurricanes show the power of the ocean. They show how the atmosphere and the oceans are intricately linked together, and they can show some of the raw power of nature and what happens in the intersection of where ocean processes meet where humans live. So the dynamic relationship between humans and their environment. We're not separate than our environment. We're part of our environment. And sometimes our environment has extreme weather situations, as is the case of hurricanes, a natural phenomenon highlighting the connection between the atmosphere and the ocean. Thank you so much. I'll see you again.